manipulate radicals through different operations. Second page, please. We're going to start off by talking about multiplication. Okay. Start off by talking about multiplication. Yesterday we learned some vocab words, right? Not yesterday, but the day before. If you have n to the 8th, or a to the nth power and b to the nth power, right? What is the n? What do we call that? Index. Good. And the a? Radicand. Very good. Okay, so when we're multiplying and similarly dividing radicals, what we need to be concerned with are the indexes. You cannot multiply or divide if you don't have a common index. Common meaning what? The same. Okay, so come down here. We've got a to the nth power times b to the nth power. What do you think that's going to become? AB to the nth power. Good. So now to get that funky little symbol that we have here, it's control caret. You want n as your index. I must have my caps on. And then underneath the radical, where the radicand is, it's going to be AB. Why is my caps on? Thank you. Okay, so that is multiplication of radicals. So you have a common index. All you're doing is multiplying the radicands. Are we okay with that? Okay, go to the next page. Here's our first example. We've got the square root of 2 times the square root of 8. When you multiply that together, you get square root of 16. Square root of 16. Okay, am I done? No. What's the square root of 16 equal? 4. 4. Very good. Easy? It will get harder. Not too much harder, but it will get harder. All right, so let's look at the next page. We have square root of 3 times the square root of 12. I want you to go ahead and try the next three. See how you do. Okay, I forgot to start recording. Square root of 3 times the square root of 12 is the square root of 36, which reduces to 6. Second one, cube root of 3 times the cube root of negative 9. When we multiply, we get the cube root of negative 27, which reduces to negative 3. Very good.
If you were to put a negative number like that, like negative 27, like the calculator page, would it come up with an error? Or?
No, it come up as negative 3.
What? How do you get negative? Okay, I know you reduce. But then, what do you do with the cube?
Goes away.
Why?
What the cube is showing us, it's telling us how many times we need to repeat a number. Okay? So negative 3 times negative 3 times negative 3 is negative 27. That's what that cube means. When we're dealing with squares, this is a 2, right? It's 6 times 6. So do you see what that index is doing? What it's showing us?
I was dividing the number.
Don't divide. Okay, so we're down here, the last one down here. When we multiply these together, what do we get? The fourth root of what?
Negative 16.
Negative 16. Now, is there a number that we can multiply by itself 4 times that'll give us negative 16?
2? 4.
No.
Okay, here comes the problem. 2 times 2 times 2 times 2 is 16. Negative 2 times negative 2 times negative 2 times negative 2 is 16. Can I get a negative when I have an even index?
No.
No. Can I get a negative when I have an odd index?
Yeah.
So there's our rule. Okay? When you have an odd index, you can deal with negative radicands. When you have even indexes, you cannot have a negative radicand. So this stays the way it is. Nothing else you can do. Okay? In a few weeks, we're going to learn about something called complex numbers or imaginary numbers. Then we're going to start dealing with these.
So what would it
Okay?
come up if you put that in the calculator?
If you put this in the calculator, it might come up as negative 2i.
Is this like
Non-real.
real?
Yeah. It's an imaginary number. And we'll talk about those later.
You just know to leave it the way it is.
No, what we'll do is we'll change our calculator so that it'll work with them. But we're not going to do that for a couple weeks.
So what will be the answer?
If we went further, The answer would be 2i. And we're going to learn that in a couple weeks.
Don't put that.
Don't put that. You're going to leave the fourth root of negative 16. Okay? We all right?
Oh.
You suppose. Okay. So let's go on to the next page. Now we're going to get into expressions. We're going to start putting in our variables and learning how to work with radicals of variables. Okay, so this is where it gets a little bit trickier. We have the square root of 72x cubed. So what we need to do is we need to learn to simplify. Okay? When we simplify radicals, what we're doing is we're breaking them up into two pieces, two factors. One of those factors has to be a perfect square or a perfect cube. See them over there? Perfect square or perfect cube. One of the factors has to be. All right? So let's talk about this one first. What we're going to do is we're going to split this up so we're dealing with numbers and variables. So everybody's going to put in the square root of 72 and the square root of x cubed. Why can I do that?
How did you multiply and still give you the same answer?
Perfect. If I multiply them, it puts it back the way it was. Okay? All right, so now we're dealing with this, right? Let's reduce 72 first. I need the factors of 72, one of which has to be a perfect square. 36 and 2. Why am I going to pick 36 and 2 over 9 and 8? It's the highest. And 8 you can reduce again. So we're going to do the square root of 36, square root of 2. Now let's deal with the x. Can I take the square root of x cubed? No. But can I break up x cubed so that I can take the square root of it?
X squared and x.
Perfect. X squared and x. See how we broke it up so I'm able to take the square root of something? So we can pull those apart because we know x squared times x is what? X cubed. It brings me back to the original. God bless. Okay, good. Square root of 36?
6.
Can I do anything with the square root of 2?
No.
So hold off on that for a second. Square root of x squared?
X.
Can I do anything with the square root of x? So what do I need to do with this square root of 2 and the square root of x? Yeah. So we're going to have 2x. So my solution becomes 6x square roots of 2x. How do we do with that?
Awesome.
Anything facetious?
Wait, so how squared? Yeah.
Where'd the square go? What's the square root of x squared?
So how come you don't do anything with 2, but you do it to x just because you can?
You can't. You can't take the square root of 2. Square root of 2 is an irrational number.
So the ones you reduce, you put together, and the other ones you split.
Correct. Okay, B. Boys are creeping me out. B, cube root of 80, n to the 5th. So now, are we talking about perfect squares anymore?
No.
No, we're in the cube section over there, right? Cube root of 80, n to the 5th. So I want to reduce 80. I want to break it into two pieces, one of the factors being a perfect cube, and I want to break apart n to the 5th where one of them is a perfect cube. Okay, so take a second and see if you can figure that out. Okay, so I'm going to break apart 80. We're dealing with cubes. We're not talking about squares. We're talking about cubes, cube roots. Okay, that means you have to multiply a number by itself 3 times to get it, not 2. Okay, so to break apart 80, what are you going to use for factors? 8 and 10. Now, when you do this, you have to use the cube root, not the square root. Cube root of 8 times the cube root of 10. Okay? Now we need to break apart n to the 5th. You're going to use the cube root of n to the 3rd, because you can take the cube root of n to the 3rd, right? And what's left over?
Cube root of n squared.
Cube root of n squared. Good. Okay? What's the cube root of 8? What's the cube root of 10? You can't take it, so you leave it. Can't take the cube root of 10, so you leave it alone. What's the cube root of n cubed? What's the cube root of n squared? You can't do it, you leave it alone. Okay, so now I've got all of this. Do I want to leave it written like that? How am I going to write it? 2n cubed root of 10 n squared. That's an R. That is it. Let's take practice. Okay. Did we get the next one done? Did anybody get the next one done? Okay. For those of you that haven't done C yet, please do C. Now, look, you're dealing with square roots now. So you're talking about the perfect squares. Okay, let's talk about C. Ready? Let's break it up. How am I going to break up 50?
Square root of 25, square root of 2.
Okay, 25 and 2. Okay. X to the 4th. What's the square root of x to the 4th? X squared. So you don't even have to break that up. There's no need to. Okay? There's no need to break it up if you can take the square root of it as it is. Okay? Square root of 25 is? Square root of x to the 4th is? X squared. Okay? The way that you figure that out, what's the index?
2.
Is it a multiple of 4? Or divisor of 4, I guess I should say. Okay, so if the index is 2, the power is 4, we divide x squared. That works for all the square roots. If this is a multiple of the index, you can divide. Okay? What am I left with? That's it. Okay? Last one here. Okay, how am I going to break up 18? 9, 2. Do I have to do anything with x to the 4th?
No.
Okay, so when I reduce this, I get 3x squared. Good.
It's really annoying how it does that.
I know. And perfect. How many people got those right? Majority. Good. Okay. All right, go to the next page. Let's get a little bit bigger.
No, that's not. I don't like
A little bit bigger. Okay? Same thing. You're just multiplying. We know that we have exponential rules, right? When you multiply two variables, what do you do with their exponents? Add them. When you multiply two variables, you add the exponents. When you multiply two variables, you add the exponents. When you divide two variables, you subtract. When you raise a power to a power, you okay. Okay, so do we have a common index? So can we multiply? Yes. Do not lose the cube. See everybody changing it to square roots. Don't do that. It has to say cubed if it starts cubed. So everybody put in control caret cube root. Has to stay cubed. We have common indexes, which means we can multiply the radicands. So all we're doing is multiplying. 54 times 5. X squared times x cubed. X to the 5th. Good. Y cubed times y to the 4th. Good. Very nice. Okay, so let's talk about simplifying this. We're dealing with cube roots now, right? So we're in the cube root column over there. I want to break down 270. I'm going to break it apart. So I need factors. Okay? 270, look at the cube column. What do you think you're going to use? 27 and 10. All right, so put in your new cube root. Oh, wrong one. You told me it was what? 27 and 10. So I'm going to keep it all under one radical for the sake of space. Okay. Now I'm dealing with x to the 5th and y to the 7th. Remember, we're dealing with cube root, so I want to pull it apart into factors where I'm going to be able to take the cube root of one of them. X to the 3rd. Good. Very good.
Do the same thing for y.
You're going to do the same thing for y, except are you going to use cube this time?
Yeah.
Really? X to the 6th. Why am I going to use x to the 6th instead of x cubed? Yeah, what's the cube root of x to the 6th? What are you going to do with those indexes? The index of the power. Divide them, right? So you could do x cubed, but you're going to have to reduce again afterwards. Okay? All right, so we get y to the 6th and y, just y. Y to the 1st, you put a 1 in there if you want. It's implied, you don't have to put it. All right, so let's talk about what we're going to pull out. Look at all of our perfect cubes. What do we have? 27, cube root of 23, 27, which is 3. Good. Can I take the cube root of 10?
No.
Nope, so we're going to leave it aside for now. Cube root of x cubed? Cube root of y to the 6th?
Squared.
Y squared, because y squared times y squared times y squared is y to the 6th, right?
The first section.
There you go. Better? Good. Okay, so we pulled out all of our perfect cubes, right? What are we left with?
10.
Cube root. Good. What are we left with?
10x squared y.
10x squared y. Perfect. Very nice job, you guys. Good. Okay, so I want you to try the next one down. See if you can do that. Now, the 3 and the 2, those are just constants that are sitting out front. Those get multiplied as well. That constant that's going to sit out front stays until the end and then gets multiplied with whatever you pull out. Okay? So give B a shot. See what you can do. That'll be around to help you guys. 6 square roots of 7 times 21 is 147. X to the 6. Y squared. Whoops. Are we all okay with that?
Yeah.
Okay, so we need to start pulling apart now. 147, how are we going to break it apart? Very good. 49 and 3. Do I need to do anything to the x to the 6th? No. Do I need to do anything to the y squared? No. Okay. 6 times square root of 49 times square root of x to the 6th x cubed. Square root of y squared. What do I have left in the radical? Okay, so when I put them together, I get, oops, not that. What do I get?
42 x cubed. Y square root of 3.
Perfect. That's not a 3.
Yeah, it's square root of 5.
Okay, how do you do?
I did it.
Good.
I did longer.
You did longer.
Yeah, I did.
Still got the same way though. Okay. We're not going to make it to division today, or foiling, or like radicals, or the other half of the lesson. So, what I want you to do tonight, the worksheet that you have in front of you, I want you to pick 5 multiplying. Nope. I want you to pick 10 multiplying. Any 10 that you want. Okay? And we'll finish this lesson next class. Okay, so on the worksheet for multiplying radicals, pick any 10. The weekly project is going to be extended at class.
So it's not due Monday?
It's not due Monday, it's due Wednesday.
Awesome.